The Unknown Universe. The Expansion of the Universe. A presentation by Kishakanthan Sivapragazam. The purpose of this presentation is to provide a new perspective of understanding the expansion of the universe, and answer the most important questions that humans have been wondering about for centuries, such as: why does the universe appear to be expanding in every direction? Where did the event of the Big Bang occur? Is there a center of the universe? Why does time flow in a predetermined direction, toward the future? Universe's expansion may not be the same in all directions. One of the fundamental ideas of cosmology is that everything looks the same in all directions if you look over large enough distances. A new study using data from NASA's Chandra X-ray Observatory and ESA's XMM Newton is challenging that basic notion. Astronomers using X-ray data from these orbiting observatories studied hundreds of galaxy clusters, the largest structures in the universe held together by gravity, and how their apparent properties differ across the sky. One of the pillars of cosmology, the study of the history and fate of the entire universe, is that the universe is isotropic, meaning the same in all directions, said Konstantinos Makas of the University of Bonn in Germany, who led the new study. Our work shows there may be cracks in that pillar. The history of the expansion of the universe. Edwin Hubble, Albert Einstein, and many other great minds had a fixed view of what the universe was like. But in 1929, in Mount Wilson, Edwin Hubble discovered something that changed everything. During that year, scientists discovered something that turned the accepted model of the universe on its head. The astronomer Edwin Hubble discovered that almost all the galaxies beyond our Milky Way were moving away from us. Therefore, he interpreted that the universe must be expanding. This discovery was one of the greatest intellectual revolutions of the 20th century. How did Hubble go about detecting the speed and the direction of the galaxies billions of light years away? Think of how the sound of a siren changes as it moves toward and then away from you. As the sound waves from the siren move toward you, they are compressed into higher frequency sound waves. As the siren moves away from you, its sound waves are stretched into lower frequencies. This shifting of frequencies is called the Doppler effect. A similar thing happens to light waves. Light is made up of waves and each color has its own wavelength. Blue light has a shorter wavelength and red light has a longer wavelength. But when an object moves in space, the wavelengths of light appear to change from our perspective. If the object is moving toward us, the wavelength gets squashed and appears to be more blue. If the object is moving away from us, the wavelength gets stretched out and appears to become more red. We call this effect redshift. The speed and direction that a galaxy is traveling can be deduced simply by observing its color. In 1929, that is precisely what Edwin Hubble observed, that the galaxies were moving away from us. He had measured the speed of galaxies at different distances from us, and discovered that the farther they were, the faster they were receding. This discovery of the expansion developed the idea of the universe and provided the first evidence for the Big Bang theory, which describes the birth and evolution of the universe. Even though the discovery was recognized as important, the notion that we could understand the Big Bang seemed steps too far at that time. After a few decades during the 1960s, astronomers became aware of microwave background radiation that was detectable from all directions. Known as the cosmic microwave background, the existence of this radiation has helped our understanding of how the universe began. Cosmic microwave background implies that about 14 billion years ago, all matter was condensed onto a single point of infinite density and extreme heat. Due to the extreme heat and density of matter, the state of the universe was highly unstable. Suddenly, this point began expanding, and the universe as we know it began with a Big Bang and has been expanding ever since. Yet there is no known center to the expansion. Rather, the whole universe is expanding, and it is doing so equally at all places, from any vantage point, as far as we can tell. As such, the standard theories of cosmology states that there is no center of the universe. More recently, measurements of the redshifts of supernovae indicate that the expansion of the universe is, in fact, getting faster in its acceleration as it gets bigger. This is largely a result of the mysterious dark energy that pervades the universe. Dark energy is an unknown form of energy which is hypothesized to permeate all of space. The first observational evidence of its existence came from supernovae measurements, which showed that the universe does not expand at a constant rate, rather it's accelerating. There is something about this accelerating expansion of space that has extraordinary and unexpected consequences. What is crucial to understand is not simply that the universe is expanding, or the expansion is accelerating, but the unexpected way in which it does accelerate while expanding. From Hubble's data, the observation of moving galaxies holds further secrets even after almost 100 years. The secret that this discovery holds is that the universe in four-dimensional space-time is expanding only in one direction, outward from the single point in space, where the event of the Big Bang occurred. The new perspective of understanding the expansion of the universe. A simple way to help visualize the expansion of the universe is to compare galaxies with cyclists riding at different velocities. Imagine a small thought experiment that Ben, Alex, and you are riding bicycles on a straight road, in the same direction, at different velocities. Say Ben is riding his bicycle slower, and Alex a little faster than you. After a while, if you notice them, Alex, who is riding faster than you, will look like he is moving away from you, and Ben, who is riding slower than you, will also look like he is moving away from you. If you observe carefully from your point of view, Ben will not only look like he is moving away from you, but also he will look like he is moving in the opposite direction. When you observe Alex, you will feel as if you are moving away from him in the backward direction. It is bizarre to understand that while all of you are in motion in the same direction, from each of your points of view, everyone else appears to be moving away in different directions. After a certain interval, Alex and Ben will look like they are receding away from you, so the farther away they get from you, the faster they seem to travel. Which means the space between the three of you would be expanding at an accelerating rate. In other words, Ben and Alex will be redshifted from your perspective. Now imagine the same thought experiment with a few more cyclists who are riding on the same road, in the same direction, but at different velocities proportional to their distance. The further away a cyclist is from the starting point, the faster they are moving. In other words, the cyclists riding in front of you are faster, and the cyclists behind you are slower. In this case, you will notice that each cyclist is moving away from you at an accelerating rate. In fact, this is true from everyone's point of view. The farther away they are from you, the faster they appear to be moving away from you. In other words, the further away they are, the more their redshift would be. The effect of light shift, redshift, that one receives when galaxies are moving in the same direction with a velocity that is proportional to their distance from the starting point. The further away a galaxy is from the starting point, the faster it is moving, is the same effect of light shift that one would receive when the galaxies are moving away in all directions. In other words, it is indistinguishable whether a galaxy is moving in the same direction or moving away in a different direction, from the effect of light shift that we receive. This strange phenomenon made Hubble and other astronomers' observations, even today, believe that the galaxies are moving away in all directions. Based on the results of the above thought experiment, it clearly alters the picture of our current understanding of the universe. The expansion of the universe is not taking place in every direction, but in fact it is taking place only in one direction in three-dimensional space and four-dimensional space-time, outward from the Big Bang singularity, which is where everything in space was condensed into a single point before the moment of Big Bang. As space began to expand, the space between every galaxy started to move away from each other, outward from this starting point with a velocity that is proportional to the distance. The more distant space is from the point of origin, the faster it stretches. As a result, the further away a galaxy is, the faster it appears to be moving away. The different rates of the stretching of space is caused by the mysterious force of dark energy, which is getting stronger, relatively, as galaxies move apart from the point of singularity. There is clear evidence to advocate that the universe began nearly 13.8 billion years ago. However, the location of the event of the Big Bang, the center of the universe, seems to be undefinable, up to now. Since galaxies appeared to be moving away from each other in all directions, it seemed impossible to comprehend that the universe is expanding only in one direction since Hubble's time. As a result, astronomers had begun to accept the idea that the expansion of the universe has been happening in every direction without further arguments. Since we now have a new way of understanding that the expansion of the universe is happening in one direction, ever since the beginning of the universe, if we run the picture of the expansion backward, it would imply that there had to be such a location as the center of the universe in space, where everything in the universe today came from. However, the center of the universe did not exist only in space, but it existed also in time, therefore the center could only be located if we travel back in time. The absolute rest. Absolute rest is a new idea which defines a point in space that a body would ultimately reach while traveling in the opposite direction to the expansion of space. Traveling in the opposite direction to the expansion of space means slowing down from the speed of being drifted in the direction of the expansion of space due to the expansion itself. The body would reach the specific point of absolute rest when it exactly reaches the speed of the expansion of space. That motion of the body equals the motion of the expansion of space and comes to the state of ultimate rest. At this point, the so-called body would stand still against the force of expansion, causing a total curvature of space. However, nothing could have ever become absolute rest since the event of the Big Bang. To occupy this point in space, a body has to condense the total mass and energy of the universe together, at a single point in space. Nothing with mass travels or can travel backward toward the point of the Big Bang, the point of origin, or in other words, the opposite direction toward the direction of expansion. Everything, even if it seems to travel in the opposite direction, still travels in the same direction as the expansion. Anything that is forced to travel in the opposite direction cannot move beyond the point that it occupied at an earlier time, not even the point that it occupied a second before. That means, nothing with mass can occupy space-time that it already occupied earlier. This is prevented from the point of the absolute rest. The absolute rest is a point beyond which nothing with mass can travel. The certain point can also be termed as the mass particle's cosmic space boundary. The absolute fast. Absolute fast is the fastest or the maximum speed that anything in the universe can travel, including massless particles, example the speed of light. This can also be termed as the massless particle's cosmic speed limit. There is nothing such as an absolute rest in the universe, which means everything is in motion at some speed due to the expansion of space. The speed is between absolute rest and absolute fast. The direction of motion takes place in the same direction as the expansion of space, outward from the point where the event of the Big Bang occurred. In an expanding universe, time that a body experiences depends on the speed and the direction in which it is traveling. The faster a body travels toward the point of absolute rest, the slower it moves in space, therefore, the faster it experiences the ticking of time. More about how time is experienced is discussed in the presentation of The Unknown Universe, Nature of Space-Time, published May 25, 2020. Conclusion. Astronomers observed galaxies were moving away in every direction from the point of their observations, and the further a galaxy was, the faster it appeared to be moving away, which is the same observation that would be made from any galaxy in the universe. As such, it seemed impossible for them to picture a model in a way that could define how space could be expanding only in a certain direction beginning from a single point in space, at the same time having the model agreed with all their observational proofs and data. Unlike the observational results from Edwin Hubble in 1927, that the universe is expanding in every direction, the concept concludes that the universe is expanding only in one direction, in four-dimensional space-time, outward from the point of Big Bang singularity. As space began to expand, the space between every galaxy started to move away from each other with a velocity that is proportional to the distance from the center point, singularity. As such, the further away a galaxy is from the center point, the faster it moves. If the expansion were to run backward in space and time, it would take you to the location where the event of the Big Bang occurred, which would have been the center of the universe. An unexpected consequence of the expansion happening in one direction directly addresses the question of why time is flowing only in one direction, which is toward the future. This new perspective of understanding the expansion of the universe alters the fundamental idea of the universe and resolves the crack in the pillars of cosmology, providing clear and practical examples that the universe is not the same in all directions as it has been believed by astronomers for decades. Thank you for watching.